Hello everyone. In previous class we discussed about inductive effect and applications of inductive effect. So today I will going to start mesomeric effects. Okay. So what is mesomeric effects? This effect which operates only in a molecule having a conjugated system. Okay. Those molecules which are in conjugated system, only in that case the mesomeric effect is arises. So what do you mean by conjugated system? Any organic compound which contains alternate double bond single bond like that, in that compound only mesomeric effect is arises. So double bond, in this double bond one is sigma bond and one another is a pi bond, and here sigma bond, pi bond and sigma bond here. Okay, so see, in that case what happened, there is a pi conjugation. This effect is also called as conjugative effect, or it is also called as a resonance effect. Okay, so see here, these pi electrons compared to the sigma electrons, pi electrons are weak. Pi bond is weak bond. Okay, so pi electrons which delocalize, they will shift it here to here, and this pi bond shifted to CH2, shifted on the CH2 that is carbon atom, and gets the negative charge. So here, if the bonds here, you will get CH2 plus, single bond CH, double bond CH, single bond CH2 negative. This negative, these are nothing but the pi electrons. Again they will shift it here, and pi bond will shift it to here, and you will get this structure. Okay, so both are in their conjugation. Okay, so in delocalization of what? Pi electrons in mesomeric effects. Okay, this mesomeric effects also arises due to the pi lone pair conjugation. What do you mean pi lone pair conjugation? If 5 bonds and lone pair of another atom which are in conjugation, they will be arises that which one is the mesomeric effect. See here, this is called as the vinyl alcohol OH group which attached to sp2 hybridized carbon atom. So in the OH group there is a lone pair of electrons which are comes to here, lone pair comes to OH bond, it forms a double bond, and this pi bond will transfer to on this carbon atom. So you will get this resonating structures. Okay, and it will acquire the positive charge. Okay, so again this lone pair of electrons, they will comes here, and this again will get the this structure. Okay, there are two types of mesomeric effects. One is called as a positive mesomeric effect. It is denoted by plus m effect. In this case, see, it involves transfer of electrons away from the atom or group and towards the carbon chain. Okay, such group make the carbon chain electron rich. Okay, so in this plus n effect, if the electron donating group attached to the carbon chain, these electron donating groups, they will give its lone pair electrons to the chain. Okay, and such kinds of effects are called as positive mesomeric effects. Okay, see, these are the lone pair electrons, they will give to the here, and it will is in the conjugation. It should be in conjugation with pi bonds. Okay, lone pair and conjugation both are in their conjugation. Lone pair, and this is a bond pair in sense pi bonds. Okay, so again the groups or atoms which will donate the electron pair to the, there are some examples. See, OH group, it will show the plus m effect. OR group, NH2 group, amine group, NHR group, NR2 groups, SR group, halogen groups. Okay, so they will produce as plus m, positive mesomeric effects. Okay, so next one, that is second type, negative mesomeric effect. It involves the transfer of electron towards the atom or group. Such group make the carbon chain electron deficient. Okay, in this, if the conjugate system attached to the electron withdrawing group, this group is called as electron withdrawing group. Then this is unsaturated compound. Okay, if the unsaturated compounds which are attached to the electron withdrawing groups, this effect is arises, and it is called as the negative mesomeric effects. Electron density move away from this carbon chain, and here electron density move towards the carbon chain. Okay, so they are in the resonating structures, that is called minus m effect. There are such groups which will gives minus m effect. See, this is aldehyde group, ketonic group, CN group, NO2 group, and that is SO3H group. They will shows minus m effect. Applications of mesomeric effects. Okay, so they are very important regarding the computer exam. Applications of mesomeric effects. So by using a mesomeric effect, we can determine the stability of carbocation, we can determine the bond breaking, we can analyze the acidic nature of organic compound and basic nature of organic compound. Okay, so we'll discuss one by one. First, what is the stability of carbocation? Okay, so in exam, if they'll give these two type of structure, that is NH2, that is this carbocation, carbon contains positive charge. Okay, and here in the first case, NH2 group is attached to the CH2, and here is CH3 group will attach to CH2. Among A and B, which one is more stable? Okay, so see here, this lone pair electrons are there. Nitrogen contains lone pair electrons. It is electron donating groups. It will show the plus M effect. Okay, so this will give electrons to us here. It is more stable here. In this case, this is also electron donating group, but in this case there is not, it will not produces that is a plus M effect. It will produces hyperconjugation effect or inductive effect. Okay, so you know that in the mesomeric effect is more stronger as compared to the inductive effect. Okay, so this is more stable carbocation as compared to the CH2, that is CH3, CH2 positive. Okay, so see the order of electron donating effect, that is NH2 is more NH2, it has more power to donate electrons to the carbon as compared to the OH, as compared to the OCH3. Okay, so see here, among these A, B, C, which one is more stable carbocation? See here, NH2, CH2 plus, CH3, CH3, CH2 plus, OH, CH2 plus. Okay, here this will produces effect positive, that is positive inductive effect or hyperconjugation effect. It both A and C both will produces mesomeric effect, but the power of NH2, it is a more donating. It will gives more electron towards the to stabilize the positive. So which one is a more stable carbocation? A is more stable carbocation than that of C and then that of B. Okay, so we'll take another example. Among A and B, which carbocation is more stable? Okay, so as you know that NH2, it is more electron donating group as compared to OH, and this will minimize this carbocation. This will minimizes the positive charge on the carbon atom, so it will donate a lone pair electrons and it will stabilize. So this is more stable. B is more stable carbocation as compared to the A. Okay, we will take another example. See, they are given this kinds of structure. Okay, A, B, C. Among these, and they will ask which one in among A, B, C, which one is more stable carbocation. Okay, so as you know that this electron donating groups, it will produce plus M effect. This also electron donating group, this is also plus M effect. This will produce plus N effect. This is also plus M effect. But you know that this aldehyde group, this will produces minus M effect. It will withdraw the electrons. It will withdraw the electrons towards itself. Okay, so this will this carbocation is less stable. Okay, among B and C, see here, NH2 group, NH group is more electron donating groups. It will produce, it will stabilize this positive charge. Okay, positive charge should be decreases here. Okay, this also gives electrons. It will also stabilize the positive charge, but the electron donating group is more here, NH. Okay, so which order of carbocation stability? B is more stable as compared to the C, and least stable is A. You will take next example. See, among these compounds, which one is more stable? Okay, so in this compound, see here, all benzenes are same here. Okay, this carbocation CH2 plus, benzene is same here, but here what, NH2 group is there, OH group is there, CH3 group is there, NO2 group is there. Okay, so you have to identify which effect is arises. In option A, it produces plus M effect. It will produce what is a plus one electron donating capacity. That's why it will be stabilized. It will undergo resonating structures. Okay. Second, B case is also produces plus M effect. Okay. As you know that between A and B, A is more stable carbocation because NH2 group, it will produce the, it will give the electrons more easily as compared to the OH. Okay. Option C, it produces, that is electron, this electron donating group, it will produces hyperconjugation effect as well as inductive effect. Okay, it will not produces the what it you can say is hyperconjugation and inductive effect. Okay, hence as compared to, you know that inductive effect, hyperconjugation, they are less weaker as compared to the mesomeric effect. And last one, it is electron withdrawing group. It will produces minus M effect. It produces minus N effect. Okay, so which carbocation is more stable here? A is more stable here as compared to the B, as compared to the C. And that is a weak carbocation, weak stable carbocation is D, because this electron withdrawing group. Okay, so this positive charge will be increases more here, and the stability should be decreases. Okay, Second application of mesomeric effect is bond breaking. Okay, so generally we will break the bond, that is the pi bond. It depends on what kinds of atom or group of atom attached to the unsaturated carbon atom. Okay, so see here CH2 double bond CH, here is also CH2 double bond CH, here is also CH2 double bond CH. Okay, but it depends on the which kind of, here it will attach the CH3 groups, here it will attach the NO2 groups, and here it is the NH2 group. It is electron donating groups, electron withdrawing group, and electron what it is again donating group. Okay, but it will produces hyperconjugation and inductive effect. Okay, it will electron here in this case what's happened, this if it gives the electron donating groups, this pi bond will shift it to here, it will give CH2 minus here. Okay, this bond is broken here. Okay, if the electron donating group attached to the conjugated system, that is the unsaturated compounds, bond will break like this, it will comes to here. Okay, it will give positive charge, it becomes double bond here. Okay, this electron donating groups, so lone pair they will comes here, and this bond is shifted to here. So bond breaking is nothing but which kind of group attached to the unsaturated conjugate system. It depends on that, bond breaking can be takes place easily. Okay, so see one example I can. Okay, here a compound which has two that is carbocation, one is alpha, another called is beta, and OCH group attached. Okay, so here first of all it is lone pair electrons, and here is a double bond conjugation. Okay, if I shift this bond, which carbocation is will more stable? In exam they'll ask which carbocation is more stable. Okay, so see this lone pair electrons, if it shifted here, okay, and if it comes here, okay, so you can say if it shifted here, and if it comes here, pi bonds comes here, it is negative charge, and this is what it called as the positive charge. Okay, which bond is a preferer to form? See, positive it is a repulsion. Okay, here positive it is preference, it will form here bond. Okay, so B carbocation is more stable as compared to the, that is a beta carbocation is more stable as compared to the alpha carbocation, because alpha here positive should be repulsion here. Third application of mesomeric effect, that is acidic nature of OH group. Okay, so what is mean by acidic nature of OH group? A species which use easily H plus ions is called acidic nature. Okay, so if I have two compounds A and B here. Okay, A and here is A and B. Okay, and the last among A and B, which one is more acidic in nature? Okay, so what is acidic in nature? Say if it cuts, it will plus and this is minus. Here is plus and this is minus. Okay, so among A and B, which one is more acidic in nature? Okay, so see if it contains O minus, it will undergo conjugate resonating structure. It will comes here, and this bond will shift to here. Okay, here is no such kinds of resonance. Here is electron donating group. This is called electron donating group. Okay, if it donates electrons, negative charge on oxygen is more here. Okay, so hence it cannot be gives easily H plus ions. So among A and B, which one is a more acidic in nature? A is more acidic in nature. A is more acidic as compared to the B, because it produces, it will, in this case negative charge will undergo in resonating structure. Okay, so next one, among H2S, one, this is a very important question. H2 among H2S and H2O, which one is more acidic in nature? Okay, it can be dissociated into SH minus and H plus, and water can be dissociated into H plus and OH minus. Okay, as you know that the size of SH is more as compared to the OH minus. Okay, hence it can easily give H plus ions. Hence H2S is more acidic as compared to the H2O, because H2S can easily give H plus ions because of its size. OH, this size is bigger as compared to the this one. Okay, here OH size is smaller size and H size is like this. Okay, the force of attraction between these both is very much more here. Hence it cannot easily give H plus ions. But in case of this SH, size is bigger, and the force of attraction between the H plus and SH minus is more here, less here. Force of attraction distance is more, hence it can give easily H plus ions. Okay, so based on that we will see some examples. See, it will give this kinds of structure A and B, and they will ask which one is more acidic in nature. Okay, it can be dissociated in forms H plus and H plus and S minus, it form H plus and this is minus. Okay, but in this case it will comes in resonating, it will comes here, and this bond is shifted to here. Okay, this again, it will comes here, and this bond shifted to here. Okay, so see here, in this case what's happened, the size of SH is bigger, hence it cannot undergo resonating structures. But in this case OH minus in sense O minus, the size is smaller, hence it can undergo resonating structures. Okay, hence B is more acidic as compared to the A. Okay, so here what happened, because of the governing factor is resonance. Okay, here is a very less negative charge, because size is bigger, negative charge will be dissolved in that size is smaller, negative charge more on that OH minus ion, hence the negative charge is more, they will undergo resonating structures. For that reason easily H plus ions can be used. Okay, in this case the H plus ions cannot be used easily. Okay, if you take another structure, see here, in this case CH3 CH2 SH, CH3 CH2 OH, among these two which one is more acidic in nature, which one gives easily H plus ions? Okay, so in this case see here, in this case only governing factor is only size. Okay, size, it gives easily H plus because of is the size. Okay, here is not such conjugation, here is not such resonance structures, because here is not single bond here. Okay, among A and B which one is more acidic? Here A is more acidic as compared to the B, but here B is more acidic because as compared to the A, because in this case their governing factor is resonating structures, more negative charge, they will undergo resonating structures. Here is governing factor is size, bigger the size easily gives H plus ions. Okay, this is very important question. Next example, it will give ABC and they'll ask which one is more acidic. Okay, or given the order of their decreasing acidic strength of this compound. Okay, this is paranitrophenol, orthonitrophenol, metanitrophenol. Okay, so before you understood this acidic nature, first you should know that okay, this compound, okay, with respect to X, this is ortho position and this is meta and this is para position. Okay, one thing you should remember, ortho and meta, ortho and para position, there is inductive effect as well as a mesomeric effect. Ortho and para positions, it forms inductive effect as well as the mesomeric effect. But in case of meta position, with respect to X meta position, it forms only inductive effect, there is no mesomeric effects. Okay, so see, in this case see, here is inductive effect, electron withdrawing group is there, yes, it is a minus I effect is there, along with that minus I effect, minus A effect is also there. Okay, here in this case there is in the electron withdrawing group, that minus I effect is there, along that minus M is also there, it will produces, but the distance, okay, as you know that as the distance increases from OH group, the negative inductive effect, the strength is decreases. Here's negative inductive effect is more. Okay, in this case negative, only it is a negative inductive effect. Okay, so it cannot give easily H plus ions. So first you just keep E sides, A, and you will see A between A and B. Okay, so first condition is that as the size increases, inductive effect is decreases. Here is more inductive effect as compared to here. But the thing is that and the thing mesomeric effect, here is also negative mesomeric effect, it is also negative mesomeric effect. Okay, so there is no effect, there is no what we call as the double bond increases, if it is carbon single bond, carbon double bond, as the chain increases, okay, so there is no effect on the mesomeric effect. Okay, but the effect on the inductive effect. Okay, among A and B, which one will give easily H plus ions? Okay, so see here is more in mesomeric effect, more inductive effect, but the thing is that it another factor is here is intramolecular hydrogen bonding is there, that's why it cannot give easily H plus ions. Okay, so it can give easily H plus ions because here there is no such kinds of intramolecular hydrogen bonding. Okay, so it is more acidic as compared to the B as compared to the C. Last application of mesomeric effect, that is basicity. Okay, so if they will give this A and B and they will ask which one is more basic in nature. What is mean basic in nature? Which will give easily low number of electrons. Okay, so these low number electrons which are involved in resonating structures. Okay, so it will produces plus M effect. So we will not get these low number of electrons, they goes into resonating structures. Okay, so this will give the electron donating groups, the electron density of nitrogen increases, hence this is more basic as compared to the E. So B is more basic as compared to the A. Here is what plus M effect. Okay, if we will ask this structure. Okay, here is CH3 same is there, here NH2 same, here is C double bond O is there, and here is C double bond CH2. Here Okay, so among these, which one is more basic? Which one gives easily lone pair of electrons? Okay, so see here, oxygen is more electronegative as compared to the CH2. Okay, so this lone pair electrons not in the resonating structures. Okay, so these electrons pair which are not available. Hence, B is more basic as compared to the A. It gives easily lone pair of electrons. Here, lone pair is not available. Okay, because there is in resonating structures. Okay. Next, see next example, among A and B, which one is more basic in nature? Okay, here is NH2, here is NH2, here is CH3, here is CH3, but the thing is here is NH and here is CH2. Okay, so more electron density is here, so hence it can give easily you can say lone pair of electrons. So A is more basic as compared to the B. Okay, so here you see among ABC, which one is more basic in nature? Okay, so these lone pair electrons, they are involved in the resonating structures. It cannot be available. Okay, so these electrons, they will use here only. Okay, these electrons, these electron donating groups, this electron donating, hence it will increase electron density on nitrogen. Hence it can use easily electron pair. So hence C is more basic as compared to the here A and last one it is a B, because B, which the lone pair electrons not in the resonance. Okay, so C is more basic in nature. Okay, so last example, C, among A and B, which one is more basic in nature? Okay, so as you know that this is again this will undergo electron donating groups, and this will take the electrons. In the sense, here is a positive charge is generated and here is a negative charge. Okay, here again same thing is that this lone pair electrons will comes here, and this bond pair they will comes here. It will forms positive charge. But one should you remember that this positive charge is stabilized by benzene. Okay, they will undergo resonating structures. Hence, this positive charge is stable here. That's why this electron pair is you can say is more available here to donate, because positive charge can be stabilized by resonance. Okay, hence B is more basic as compared to the E. Thank you.